Hello and welcome to a 5S Practical Application course. I will start with a little scenario. Imagine you are a manager and you have 10 mechanics. At some point during the day, each mechanic was looking for a 15mm spanner. That just cost you as a manager your 10 mechanics times their £20 per hour, about £200. When getting all 10 mechanics a 15mm spanner would have only cost you £20, this saving around 90%. And the chances of the problem occurring again is 9 times less likely, as you have now 9 mechanics with the spanner. There are many ways to calculate this through Pareto analysis, stock inventory, checklists, 5S, Six Sigma, and lean manufacturing techniques. This will not only save us money and time, but through continuous improvement generate a much better work culture. 5S stands for sort, set in order, shine, standardize, and sustain, and each one of these S's contribute towards 5S's time and cost saving abilities. In this short course, we will only be looking at the sort criteria, and hopefully this will help solve our initial scenario with our mechanics. So, what is the aim of sort? It saves us money. So, as prescribed in the initial mechanic scenario where we had 10 mechanics all looking for a spanner for 1 hour before finding it, costs the company about £200. And it can also save us time. By buying 10 spanners, we would have saved 10 hours of work, and if not more, considering they each had to do the job on top of the last 10 hours. So what are the requirements for sort? Generally speaking, items and tools that are required for daily activities are separated into used and not used inside the work area. I have made a little list over there of a sort, checklist, and criteria. So we can see we've got parts and stocks and items for checklist items, machines and equipment, tools and fixture, other storage areas, and standards for disposal. If you notice the criteria, we're saying there's no unnecessary items left, all machines and equipment are in regular use, and all fixtures and tools are in regular use. If I can digress to a much simpler example, it's how you handle the food inside your fridge at home. Everything that has gone off you throw away, and everything that is still edible you keep inside your fridge. There are various statistical methods on how and what way is the best way to actually sort. Taking our fridge and our mechanic examples. If a kid is asking for ice lolly 6 times a week and chicken twice a week and milk once a week, would be the same as mechanic asking for oil 6 times a week, a spanner twice a week, and a wheel once a week. If we were to Pareto this, our top 20% is causing 80% of the trouble. In these two scenarios, just buying 6 liters of oil and a 6-pack of ice lollies would mean that for next week, ice lollies and oil won't be a problem. Therefore, we're only left with 2 spanners, 2 chickens, milk, and a wheel. So, due to solving one problem, we're only left with 25% of a problem. Our initial problem rate was 12 problems. Now we're only left with 3 individual problems due to solving the one. I have taken an example from a workshop I used to be working in, and you can see it's been dated from the 15th of November, and the second graph on the right has been dated as 22nd of November. On the 15th of November, I asked everyone working if they would just like to mark down what tools they are using. This was just done on a simple tally sheet in order for me to Pareto analysis it. If you notice the factors though, after a week, when things have been sorted, our toolbox initially was only used 60 times. When things were sorted, it's now been used over 150 times, therefore multiplying our work rate almost by 2. But not only that, if we look at the bottom end of 15th of November, we've noticed we haven't used no nuts and no cosh. If we look at a week later, we started using the nuts and cosh, thus showing that when we know what is usable, we will use it, and when we don't know what is used, we won't use it. So just by sorting something out can increase our working factor over 2 times. Here are some more Pareto examples. So I've taken the inventory inside the workshop as seen in the graph to the left. We start off with the toolbox with 460 items, goes to screws and washers, and crimps and wagos. If we did the same Pareto example on what we ordered for the workshop, we'd notice our delivery expenditure. Using the same technique as used in Pareto analysis, we draw the 80% line on our delivery expenditure. This 80% would probably cover 90% of the inventory inside the workshop. Due to our 80% line being in delivery expenditure, covering quite a lot of items, we will now be able to fill up our toolbox, screws, crimps, build materials, tapes and heat shrinks. And if there was stuff not included on the delivery expenditure, that would be fine, for we have only used half of our budget in order to complete 80% of the inventory required inside the workshop. So a sort of recap. Remember, it's cheaper to buy for something than it is to look for it. Always start with a used and not used tally list, and when you can, statistically review it to see the progress and improvements that you can make. I hope you enjoyed the slide, and I hope you stay tuned for the second S. Thank you.